Hey everyone, so today's video we are going to be talking about exponential growth versus exponential decay. Mostly decay because there's a little bit of a difference from the growth that we've been working on, okay? So just a quick reminder for problem one. Now both problems have to deal with a zombie virus, like a zombie outbreak, okay? But in problem one, you'll notice that it starts off with two people who were infected, and then after day one, they've infected two other people. So now there's a total of 4 people who are infected, okay? And then that rate is going to continue on, okay? Now there's 4,000 people in this community. So by the time you're done, you'll reach eventually 4,000. That's what the goal is, okay? So find out the information in the table, plug that into your calculator so that you can get the equation, and then you can fill out all the other information. Now, what's different on the decay, so that would be your second problem, okay, is we have some percent bars, and we're going to talk about how to use the percent bars to figure out your equation, okay? So that's what I'm going to go over in this video. So let's read the problem. It says, there's a cure. After 21,000 people were infected with the zombie virus, scientists finally have a cure. Each day they give out vaccinations, 20% of the population is cured. How long will it take for less than 1,000 people to be infected? All right, so let's highlight some important information. It says 21,000 people were infected. So I'm going to highlight that because that's going to be super important. That's actually going to be our initial value or starting point. So day 0, 21,000 people infected. Now, every day, 20% of the population is cured. So I'm going to highlight that too. I'm actually highlight that green. Okay. Now that I know 20% is cured, now the question is a little bit different because the question isn't asking about the cured people. The question is asking for infected people. Okay. So I'm going to highlight that. So that's where these percent bars over here come into play. Okay, so let's talk about these percent bars. So 100%, so look at this purple bar. 100% represents the 21,000 people that were infected total. Okay, so that was our starting point, our initial value. Now 20% of the people of that 21,000 people are actually cured. So that means not everybody is cured yet. So 20%, so notice I highlighted green, so I'm going to put 20% of the people are cured, okay? But the question wants to know how long it takes for 1,000 people, or less than 1,000 people, to still be infected. So that means, well, how many people are not cured? Well, if I know 20% of the people are cured, that means 80% of the people are not cured yet. So this blue part is the part that I really want to focus on. I basically used that 20% to help me find this part that I needed. Because if you look also at your table, I don't care about the cured people right now. I'm caring about the people who are still infected, okay? So let's talk about the parts of the equation so that way we can fill out our table and our graph, okay? So if you don't remember the parts of your exponential equation, you can go to slide 6. Now, the equation is set up y equals a, which represents your starting point or initial value, times b, which is your multiplicative rate of change, to the power of x. So let's talk about that starting point. So how many people did we start off with being infected? 21,000. So right here, I'm going to put 21,000. And our rate of change, now remember, this is the people who are infected. So our rate of change comes from those people who are still not cured, okay? That's 80%. But in order for me to put it into an equation, I actually have to change that 80% to a decimal. So 80% as a decimal is 0.80. Okay. So that's my multiplicative rate of change. So I'm going to put that equation together, and that equation is actually going to be y equals 21,000 times, right, because that's going to be our starting point, 0.80. And then to get to the power, you hit shift number 6 on your keyboard. That gives you your little power button to the power of x. So we have our initial value times our multiplicative rate of change to the power of x. Okay. So now that I have the equation, I can start filling out my table. I can create my graph and find out any information that I need. Okay. Especially to answer the question, how many days does it take to have less than 1,000 people infected? So I'm going to plug that into my calculator. And what I'm going to do, sorry, I'm clearing out my calculator. So I'm going to go to my y equals, and I'm going to plug that equation in. So we plug in 21,000 and then times 0.80. And then your power button is that little caret key right here of x. Okay. So I'm going to plug that in, and then I'm going to go to my table. And bam, there's all my information. So x's, they represent the number of days, and then the y's are the number of people that are still infected. So notice day 0, 21,000. Day 1, since only 20% were cured, that means we still have a huge population that is not cured. So that population would be 16,800. So I'm going to put that in my table. 16,800. Day 2, I have 13,440. So 13,440 people. And then I'm going to continue and fill out that table here. Okay. And when I have my table filled out, then I can start using my graph and start kind of plotting some of those points. I know there's 21,000 to begin with. I know now this is going by day 2, right? So day 2, there's about 13,000. So notice that's a huge drop, right? Now my goal is to figure out how long it's going to take for less than 1,000 people to be infected. Well, now that I have this plugged in, I can go ahead and start going through and filling out and finding how many days it's going to take. So it's going to take actually about 14 days. 14 days to have less than 1,000 people infected. And then I'm going to use that information to continue on with my graph here as well. There's some more points there that you can put onto your graph that can help you fill that out. So once you've finished up problem 2 and you have finished up problem 1, then you're going to answer these questions on slide 13 about the 2 different problems. If you have any questions, go ahead and email your teacher, and you guys have a great day.